So going back to the pizza that we initially started with, we had 4 crusts and 10 cups of cheese and 15 ounces of sauce. So we could only make 3 pizzas because we ran out of sauce at that point. So that's if everything goes perfectly. So the amount of product that we can make if everything goes perfectly is called our theoretical yield. This is something that you will always have to calculate. And you have been calculating it this whole time, we just didn't call it theoretical yield. But I wasn't watching the pizza and one of the pizzas burned. So I actually only end up with 2 pizzas. I don't end up with as many as I should have if everything went right. And so the amount that I actually end up with is called the actual yield. And in a problem, that would have to be given to you. So to find percent yield, you're going to take the actual yield over the theoretical yield and multiply it by 100. So what is the percent yield for the pizzas? That would be, I actually made 2 pizzas. I should have made 3 pizzas times 100. The unit pizza cancels, right? So I just end up with 67% yield. Yeah, 67% of what I should have gotten if everything went perfectly. Applying this to chemistry, I have a mixture containing 5.5 moles of sodium and 4.9 moles of chlorine. I want to know what is the limiting reactant and what is the theoretical yield. So I will take each one of them to product and I will calculate if I used all 5.5 moles of sodium, how much sodium chloride would I make? And so if I used all of my sodium, I would make 5.5 moles of sodium chloride. I'm going to do the same for the chlorine. So if I used all 4.9 moles of chlorine, how much sodium chloride would I make? And so if I used all 4.9 moles of chlorine, I would make 9.8 moles of sodium chloride. So to identify my limiting, there's my smaller amount. So I know that the sodium is going to run out first. So that is my limiting. When I run out of sodium, I can't make any more sodium chloride. And so that 5.5 moles is my theoretical yield. We just, you've been solving for that all along. We just haven't used that term. So this problem, I'm starting with 42.5 grams magnesium and 33.8 grams of oxygen. I'm going to solve for the limiting reactant and the theoretical yield of magnesium oxide. So same thing, 42.5 grams magnesium, 24.31 grams in 1 mole, 2 mole magnesium, 2 mole magnesium oxide, 1 mole magnesium oxide has a mass of 40.31 grams. So if I use up all of my magnesium, I will make 70.5 grams of magnesium oxide. Let's do the same for oxygen. One mole O2, 2 mole magnesium oxide, and 1 mole magnesium oxide has a mass of 40.31 grams. So if I use up all of my oxygen, I would make 85.2 grams of magnesium oxide. But I don't, because my magnesium is going to run out before then. My magnesium runs out when I make 70.5 grams of magnesium oxide. So magnesium is my limiting reactant. And 70.5 grams is my theoretical yield. So let's say in this reaction, I actually end up with 55.9 grams of magnesium oxide. I want to know what is the percent yield. So percent again is actual yield over theoretical yield times 100. So my actual yield is 55.9. My theoretical yield was 70.5. times 100. So I get 79.3% yield, which in a lab situation is actually a pretty good yield. All right, last problem. This one's already balanced. I'm starting with 86.3 grams of nitrogen monoxide and 26.5 grams of hydrogen. 44.6 grams of ammonia is produced. I need to find the theoretical yield and the percent yield. So this 44.6, that's my actual yield. There's two ways I know that that's my actual yield. The first way is that it says is produced, so it's saying this is actually what is produced. The second way I know that that's my actual yield is that ammonia is a product, and the other two are reactants. Actual yield has to be a product, right, because it's what is produced in the reaction. So I'm going to take both of my reactants, and I am going to convert them to grams of ammonia. And I'm going to convert them both to grams of ammonia because that's the unit of my actual yield. So the actual yield and the theoretical yield have to be in the same unit. So 2 mole NO, 2 mole NH3, 1 mole NH3, 17.04 grams. So if I used up all of my nitrogen monoxide, I would make 48.9 grams of ammonia. Let's find out if I used up all of my hydrogen, how much ammonia I would make. So if I used up all of my hydrogen, I would make 89.4 grams of ammonia. But I don't, because my nitrogen monoxide is going to run out first. So nitrogen monoxide would be my limiting. My theoretical yield is what I just solved for, the 48.9. So percent yield, again, is actual over theoretical times 100. So my actual yield is 44.6. My theoretical yield is 48.9 times 100, and I get a percent yield of 91.2%.